Hello and welcome to today's online seminar, GPU Power for your AI applications, scalable and easy to use. My name is Patricia Salort and I will moderate today's online seminar. Dr. Florian Albrecht from Spatial Services will do the presentation that focuses on selecting a GPU quota that matches your processing needs, opportunities to monitor the utilization of your EOLab resources, tools for scaling your VMs and processing capacities, and possibilities for optimization in AI development to limit the need for scaled resources. Please feel free to type your questions into the chat. We will then give the answers after the presentation and the Q&A time. And after the online seminar, we will open a survey and we will be very happy if you would answer the questions. And now I will hand over to Florian. Thank you very much.
So hello from my side. My name is Florian Albrecht. Let me share my screen and start with the presentation. I will present to you today the talk, GPU Power on EOLab for your AI applications, scalable and easy to use. So my name is Florian Albrecht. I come from the company Spatial Services. We are situated in Salzburg, and our main focus is development of EO applications and spatial geospatial service development. My presentation will be about, this is the content that I will present to you today. I'll give you a short introduction about why to scale up processing capacities. So from my talk, I will focus on scalability, and I leave the easy to use part for you to decide. I think that's more appropriate here. So I will give a short introduction, then I will present a case example for dealing with increased resource needs of a developer team by using EOLab resources. I'll first go to present you how the team's resources are set up on EOLab. I will present you two strategies how to deal with the increased resources. And saving credits is one thing, sharing resources is the second one, and I hope this will both help you to exploit the processing capacities of EOLab more efficiently and see how to scale your applications on it. I will give you some further options and then I will conclude. So why to scale up processing capacities? I will show you one example that came up this summer in our team. So we did a test run for deep learning workflows on a virtual machine on EOLab, where we picked a classification workflow from the Esri tutorials, palm tree detection. And so the first thing was getting the image data and the samples in, then doing the training, and then doing the detection and producing an output that represents the palm trees selected in that by the examples. Our test was focused on trying out what kind of resources are necessary on EOLab. You see, ArcGIS is a software that runs on Windows. So that was the first problem that we had, because we could not choose a GPU-supported virtual machine, and instead we took the HMX-large virtual machine flavor to run this test. We did several other tests, but this one is more expressive in how you can treat a machine and try push it and not getting anywhere. So downloading, importing is quick. Creating training samples is also really quick. Creating image chips is also fairly quick, but training the deep learning model is not quick on this machine because of the lack of the GPU. So we decided to cancel this process after too many hours. And at least what we did, we tested whether the model worked well, and we picked a small image subset and used the last checkpoint of the model. And for the small image subset, we were able to get satisfying results, but there was maybe 10 or 20 palm trees and nowhere near where we wanted to get there. So the naive thinking out of this could be that you decide, well, we need more power. Okay, we need to check how to get that, and we need to check how to solve our problem with a GPU-based machine. On EOLab, we would need to switch to Linux because EOLab does not support GPU for Windows machines, and so that would be one of the tricks that we can do for this example. However, I think that the majority of tests that are running on EOLab are more mature than our approach and are definitely closer to exploiting the resources that are there. And nevertheless, I think I can show you here how to handle an increased need for resources. So when scalability might be an option, which means adding more resources to run the processes better, when does the need occur for increasing the EO cloud resources that we have? So one thing is that we imagine that you are a developer team and an additional developer joins your team, and you already used all the resources of your quota, and then you have to figure out how best to deal with the situation. Or your projects, you get more projects, you get bigger projects, you try to do more processing. That would be the second option. I think you can imagine more reasons why to scale your resources. What I want to present today is options to show you how to deal with the increased resources. The first step is selecting a quota, a GPU quota and virtual machine setup that matches your processing needs. So if you already know your processing needs, that's an advantage. Then you already know how large your quota needs to be. If you test and figure out how it works, then you also will know how large your processing needs will be, and then you can adapt this. The second thing is to understand how you use up your processing resources. There are some opportunities to monitor the utilization of your EOLab resources. That will be part of my talk today. And tools for scaling your virtual machines and processing capacities. I will point you where to find them on EOLab. And possibilities for optimization in AI development to limit the need for scaled resources. This was an original plan to be included in here. I decided to only give you an outlook on that, but I think there is definitely an opportunity for you to see that maybe without asking for larger resources, you can do more processing and more research. So coming to the case example, dealing with increased resource needs of a developer team on EOLab resources. So the cloud, the EO cloud, EOLab sits on a data center. And so this data center hosts a large amount of EO data for us to process. We have more satellites, increasing resolution, and we also we have a lot of images, and the acquisition takes place much more often. So our data center will also host way more EO data in the future. And that's why we go there and we use GPU processing, artificial intelligence, to speed up our processing to enable to exploit this vast archive of EO data. And the data center has these processing capacities to run AI models on it. And that's why we go there, and that's why we want to have our quota there. So the resource package on the data center that we get is a small part in there. In the data center, you get CPUs, GPUs, RAM, and storage, and you can then decide how best to set it up and see how it fits your needs. And the access to the shared network volume with EO data is part of this. On EOLab, we have those 8 standard packages that you can get, that you can request. They differ by the number of vGPUs and amount of RAM and storage, and also on the availability of vGPUs. So graphic cards of the type A100 and A6000 are there, and depending on your needs, you pick what you want. The duration of the packages lasts from 3 months to 6 months, but they are also extendable, and just you need to do a request for this. What is also included is or what also describes each package are the credits. So there is some flexibility in there. You can use up your credits quicker, but so the 3 months for using a GPU package will work with the standard reference infrastructure that's listed there. And if you want to use it up quicker, you can, but the credits will not last until the end of the 3 months then. So the options for setting up virtual machines, there are different hardware flavors. These are the hardware flavors for GPU machines, and they show you how many slices of a vGPU you get for processing. So, for example, the VM.A100.1 will give you 1 slice of the GPU, and A100 GPUs are split up into 7 slices. So the maximum package that you can get is a VM, includes 1 full virtualized GPU, giving you the 7 slices. With the A6000, you have 8 slices. And with the VM flavors that are there, you can split up your resources. So imagine you have the situation of this developer team here with the objective to develop deep learning models for EO data processing and apply a resource-aware mode of operation. So yes, processing is one thing, but also knowing how you use up the resources is the second thing. And your team consists of a GeoIT developer, we call her Tamara, and 2 master students, Chris and Andrea. And it is expected that a third master student will join soon. And the current setup of the virtual machines in the package is that there is one VM A6000.2, so VM with 2 slices, and 2 VMs with 1 slice of a A6000. And with additional volumes and 1 terabyte in total, you use up the reference infrastructure that will last you for 3 months to use this package. And the benefit of splitting resources is that one virtual machine exists for each user and you avoid conflicts of usage. So there's no, everybody has their own resources and they have to deal with it no matter what. The point is, when you already have used up your entire resources, you have to think how to save resources for an additional virtual machine in month 3. So imagine that you you know that already at the beginning that 2 months later there will be an additional team member, then you have to go that way. One way is the strategy 1, I called it, save credits. First step, how to monitor your credits. If you go to the to your profile, you will find the section billing and reporting and wallets and contracts there, and it is possible for you to see to export your used up credits as a CSV file. So you get a table that lists you each product that you have. So for example, the HMX large or the EO2.large. These are other virtual machines with a specific flavor. In the case of the team that I described, we would have one virtual machine with a A6000 with 2 slices and 2 virtual machines with 1 slice. And then you get an amount in euros, in credits, and the time as long how long the virtual machine is already running, and some more information about the virtual machine. And then you can look at the credits and you can make a chart of it that shows you how the virtual machine, how the credits get used up over time. Just to note here, there I included a link to the contract and wallets where they are described on the EOLab knowledge base. I include a table here that's available for and shows you the amount of credits that are used up per hour for each of the different types of virtual machines. In the middle section, you can see that, for example, the virtual machine flavor A6000.1, so one of the GPU flavors, will cost you 48 cents per hour, 48.45 cents per hour to use the virtual machine. If it's running, so your package gives you 5,000 credits, that's an average per month is 1,667. And to run a VM.A6000.1 virtual machine, within 1 month you use up 360 credits. And running a VM with 4 slices, that's almost 2 euros per hour. It's 4 times the amount of the virtual of 1 slice. So 1,441 credits per month get used up if you use the 4 slices at once. And that's almost the amount that you get for your package. One way to go there, let's just go one step back. So if you pay credits per hour, it would be one strategy to say my virtual machine, when I don't use it, I turn it off. And there's a way to turn it off that it doesn't use credits, which is called shelving your virtual machine. And that's this page about how to shelve your virtual machine is explained in the knowledge base. I included the link. Basically, you go to the OpenStack where you manage your resources, go to instances, go to the virtual machine that you want to shelve, and then you go to the drop-down menu on the right where you find Shelve Instance. If you click that, the instance gets shelved, and then it doesn't use any more credits. And the only way it uses credits is as an image. So what happens is that the OpenStack makes an image of the virtual machine, turns off the virtual machine, keeps the image, and whenever you want to unshelve it, it reloads a virtual machine from the image that is there. And this can be done with the command unshelve coming up from a shelved virtual machine if you pick the drop-down menu. So what's the opportunity of that? Shelving virtual machines doesn't cost credits afterward. So a virtual machine that is shelved doesn't cost any credits. Imagine that your team would not use your virtual machines 24/7, so having it running for 24 hours, 7 days a week, but instead only during the office hours. So running 8 hours on 5 weekdays, then you would really push down your consumption of credits, and it's not anymore the 1,667 per month, but a little bit over 500 that you spend per month. And thereby you see that by using the shelving, you can the shelving option, you can make room for more resources. So you would be able to add another virtual machine for your 4th person or even a 5th person, or you would even be able to do to use a virtual machine with a with 2 slices instead of 1 to modify your credit consumption and to modify the setup of your cloud resources and doing this. So that's a good opportunity to do this with shelving. One thing that you need to bear in mind is that everybody who uses the virtual machines and is supposed to shelve them when he leaves the office would need access to the OpenStack as well, where they can turn off their virtual machine. The second strategy that I want to show is about installing multi-user virtual machines instead of a single, instead of split virtual machines. So imagine that your team merges all their resources into one virtual machine. You won't have 3 different virtual machines anymore, but one that hosts all your users and all your processes. What you would do is turn off all virtual machines except for one. You would perform resize instance for that remaining virtual machine. So you can keep that one virtual machine setting and do this. And then you can create accounts for all team members. Afterwards, you should monitor the sharing together so that you can understand who uses which amount of credits. The resize process, that's maybe this tool for scaling up your resources that you can do. What you would need to do is to go in OpenStack to the drop-down menu for that virtual machine, and you can select Resize Instance there, and it will show you the old flavor of your virtual machine and give you a new flavor for the virtual machine, where you can select which one you want to pick, and of course that depends on the amount of resources that you have. But there you can keep your old virtual machine and rather include more hardware in it. And that's how this resizing of the instance works. And when you have done that, when you have selected your new flavor, you just go to resize, click on this button down here, at the lower end of the dialog, and the resizing is prepared, and then you have to either confirm it or you can also you can revert it as well. So as we want to resize, we would click confirm. And with this process, you have a virtual machine that's more powerful than before. And then you can do your processing and use more resources. So what's the advantage of this resizing and using one virtual machine instead of 3? There, it's about sharing resources, but you also should monitor your resources. And this will also illustrate how the sharing would work. On Linux, you have the log files. So if you go to Linux and type the command last, then the login history of your virtual machine is presented. And from this virtual machine, from this login history, you can prepare your monitoring tool. You compile a chart to visualize occupancy of your virtual machine over time by user. So, for example, EO user and EO console, those are the two users that each of the virtual machine has. And you can make new users, Tamara, Andrea, Chris, and the log will show you how long people have been logged in, and then you can decide how to display that. I did a display over weekdays here, Monday, Tuesday, Wednesday, Thursday, and so on. And in that case, you can see that over the weekends, nobody was logged in. During the week, the EO user was the account that was logged in the most. The second thing that you can do for monitoring is monitoring the resource utilization of your virtual machine over time. And so you would look for the use of GPU, CPU, and RAM. To get data about hardware utilization of a virtual machine on Linux, you can try different commands for looking up the CPU utilization. There are some options here to make an uptime log for every second and check whether the CPU is busy. Other options for logging CPUs, memories, and processes are included in the links here on this page. And you also can go to check the utilization of the GPU, and the link will present you where to do that. The key content of the command is that you go to NVIDIA-SMI and query the GPU timestamp and the utilization of the GPU and the utilization of the memory. And then you get information about this. And imagine to combine that with your login times of specific users. Then you can check how long the GPU usage was for specific login times. So in this example here on the right, you see that in the first week, the GPU usage of the EO user was not that large, but there's this one day, the Tuesday, where the EO user was logged in for a long time. And the week afterwards, you would see 2 days where the GPU was running through, maybe testing a script or doing a deep learning model when it's mature enough. So this presentation shows you how the usage of the GPU, the utilization of the GPU may not be fully not going through the entire time when a user is logged in, but there's also time when users just do interaction with the code to improve it, and afterwards doing the running. So probably with this setting, to have multiple users on one virtual machine, you can fit in much more processing than if you have the split up setup, where you have 3 virtual machines for each user, and people would only be able to use their own slice and not the slices of others that nevertheless might be idle. So that's why there's an advantage in sharing the resources. What you should do is to make a scheduling system. So everybody should be assigned some certain time when they can use the GPU. And then you have a calendar for GPU time slots for each user. And to show this example, you have Tamara at the top, Andrea in the middle, and the login times are blank, and the blue filled blocks, those are the times when the GPU is used. And so time sharing example, Tamara runs her experiments at beginning of week and over the weekends. That's her time slots. And Andrea runs her experiments on Thursdays. That's the day she got for doing this. And if you look at Andrea's Thursday, it's 24 hours that it's running. And the next day in the morning, it's still running until in the morning. So the process would run overnight in that case. The nice part is that both Andrea and Tamara can access the virtual machine to prepare code even when the GPU is blocked. So you can still work on the code and improve it until you get your time window again. So just a summary for the sharing resources strategy. Time sharing opportunities are that you can do quicker processing of experiments with 4 vGPU slices available to all instead of only 1 or 2 per person. And you intensify your utilization of the GPU. One user can exploit all GPU capacities when the others don't need them. So In total, you get fewer idle times of processing resources, and thereby can exploit the available resources much better than with the split-up system. I will not go into the details of the advanced sharing technologies here. I only want to present that Docker container is one option to go. Containerization would, if you do containerization, you would create isolated environments, containers, that share the underlying GPU resources. The benefit is that one container per user ensures that their computations run without interfering with those of the others. That does only say that your containerized environment will not be affected by the setup of a different containerized environment of your colleague, but you can manage all the settings in there your own. The containerization doesn't stop you from needing the scheduling system. So that doesn't manage the workload of the GPU. There you would need to do different technologies. So there is Docker and also Singularity. I just included the links where you can find the different containerized environments, and you can install and use Docker containers on your vGPU-enabled virtual machine. And you also can equip them with TensorFlow and so on to do your deep learning workflows. So what I showed you was the team setup, showing how saving credits can be done by shelving your virtual machine. And there you can go by, there you can also add more virtual machines for other people. And but it requests from you to organize this appropriately, that people actually don't use up the credits fully because they forgot to shelve their virtual machine before the weekend. And the second strategy was to combine all your resources into one virtual machine instead of doing the splitting, the setup that splits the resources into several virtual machines. Both these options should help you to get more efficient with using the resources, having less idle times, and thereby sort of scale your processing capacities. Other options, I want to show you them. What you can do is, if you have a standard package of A6000, you always can ask for more credits. But I think it would be suitable first to exploit the system as efficiently as possible before scaling, before requesting additional resources. Then in the end, it's a much better way to do it. It's certainly more economic to do it if you try to aim for efficiency instead of requesting more resources. And about efficiency, this slide should be about efficiency when you create your deep learning models and you want to advance them to become more powerful. One way is to go for optimization. This would make your models more efficient and needing less time for processing. And that's one way to do it. So the objective would be that you optimize your deep learning models and focus on providing better quality of the results, for example, higher accuracy, and using a smaller model footprint. And thereby you would be quicker or use less memory. Of course, these are two conflicting objectives, because the longer your model runs, the better will be the accuracy. The shorter it runs, the will not be as good. But if you there's a the solution that is proposed here is that you apply generic efficiency techniques, such as the concept of Pareto optimality, and thereby optimize for the two conflicting objectives to get an improved version of your model. So if you want to look up the reference down there, Mengani 2021, Efficient Deep Learning, a survey of making deep learning models faster, deep learning models smaller, faster, and better. You will find a concept there that will show you what kind of different approaches you can take to do optimization and how which things that you can focus on. The main issue is there that you try to keep one of your criteria that you want to optimize constant, and the other one you want to improve. For example, your runtime will only last for 6 hours or something, and you try to do everything to improve the model's quality on different things. And there are options presented in that article that you can find that might be more suitable for improving your deep learning models, and that might be interesting from a research perspective as well, and giving you the opportunity to really exploit the resources in a smart way. Let's say it that way. So this is my very short conclusion. I think I already presented clearly how this what we have focused on today. The key message of my presentation is that there are different strategies how to deal with increasing resource needs. There are some that can be done by using the tools on OpenStack, like the shelving, unshelving, and also the resizing of your virtual machine to change the setup of your resource package that you have, and being more efficient with it, with using it to scale your resources. And the strategies also include options how to improve on the focus on the side of your deep learning skills with this optimization, and thereby coming up with better models in the end. I want to point you to our e-learning platform. So there are potentially interesting courses for you coming up soon. One that's already there is two are there already. The EO browser for searching, selecting, and evaluating satellite images, showing rather more a focus of what kind of requirements exist for your EO information products that you want to process. And there's a second one, the deep learning for EO data processing on the EO cloud in TensorFlow and PyTorch. In an update, the PyTorch part will be included soon. And the other two that are coming up are the setting up cloud resources and virtual machines on EOLab, and the course Using EO Cloud Resources More Efficiently. And yeah, with that, I want to thank my colleagues that helped me preparing the content of these e-learning courses and also the content that's the basis for this talk today. And so the course development was in a collaboration between the Department of Geoinformatics of the University of Salzburg and the Spatial Services company here in Salzburg. And I also want to thank the reviewers for doing their part in this, which came from the University of Salzburg, the DLR, and of Urbito. Yeah, with that, I want to conclude my talk and want to thank you for listening and hand back to Patricia.
Thank you very much, Florian, for the great presentation. I just see that we already have 2 questions. I will read them for you. First question, is there a functionality that allows you to automatically pause the VM, for example, at 8 p.m. and restart it at 8 a.m. every day to conserve credits?
That's a good question. I have not checked whether OpenStack can do scheduling here, but that's definitely an interesting element. Maybe I would hand that question on to the technical support here.
Yes, I haven't seen anything if it's possible to do it automatically. Manually, yes, but automatically, I'm not sure. I would ask this question to the colleagues from Cloudflare if they have any idea, and I will share the answer with you because you all get an email with a link to the video of this presentation, and I will also add this information into this email then, just to make sure that everyone is informed. But I could imagine that there's some some possibility to solve it.
Yeah.
The second question is, if you want to scale up more than single GPU training, is there a way to run with multiple GPUs? For example, to use DDP or Horowod?
I myself haven't done that. I have one colleague from the University of Salzburg, Getch. He's very very proficient in GPU processing and GPU and deep learning development, and he had some ideas how to do that. I think on the EOLab platform, the setup is like this: that you get those standard packages that are there, and I think that's something to discuss with the developer with Cloudflare as well, whether it is possible to really combine larger amounts of resources into this. But from the standard packages, the way to do it is to have one full GPU as the maximum GPU support that you can get.